Hello, I want to show you how to do a kind of problem with gravitational potential energy. I want you to imagine a roller coaster, and the roller coaster is going to start over here, and then it's going to go up a hill, and then going to go down again, and it's going to go up a halfway hill, and then it's go down again. Then it's going to go up one more time, and then it's going to break and stop right over there. Okay. And my question is this hill is going to be really tall. This is an exciting roller coaster. And the height of the hill equals 40 meters. I want to know how much electrical energy I have to put in my cart to get it to the top of the hill. Once it gets to the top of the hill, all it has to do is roll the rest of the way. I don't have to add any energy to it because it has plenty of gravitational potential energy once it's to the top. So if it gets to the top, then it can roll down this hill. Then it will have kinetic energy again. And then it will be able to roll to the top of this hill. And that hill's not as high. Okay. So it's still going to be going pretty fast when it gets to this hill. So it'll have some kinetic energy and some gravitational potential energy. And then it'll go down again and it'll have kinetic energy at the bottom. Okay. And then it'll get up here. We won't write about that. It'll have to slow down and break. Okay. So I want to know how much energy it's going to take to put it up at the top because it's going to stop when it gets loaded. When it gets loaded, it's going to start over here and it's going to have electricity making it go up somehow this hill. Okay. But how much energy is it going to need? This really sounds like a gravitational potential energy problem. Let's see. Gravitational potential energy equals mass times gravity times height. All right. How am I going to figure out that problem? I have the height. I know how high it has to get. Wait a minute. I know the gravity too. Gravity of Earth is 10 meters per second every second. You guys have that in your notebook. All right. What about the mass of the cart? Well, I'm gonna guess because I don't actually know the mass of this cart right now, so I'm gonna guess, and I'm gonna say that that cart, when I put a couple people in it, there's a person and there's another person in the cart. Okay, each of those is going to be about 75 kilograms. That's about 150, and I'm going to say the cart's going to weigh 152. So I'm going to say that that cart mass is 300 kilograms. Now, you could actually weigh your cart, so you know for sure, I suppose, but it's okay to estimate, try to figure out how much that cart is, so we know how many joules it's going to take approximately. Okay, so I'm going to go here, and I'm just going to solve this problem now. The mass is 300 kilograms. The gravity on Earth is 10 meters per second every second, and the height is 40 meters. Okay, so I'm going to have to multiply all of that out. So I'm going to grab my calculator here, and I'm going to take 300 times 10 times 40, and that equals 120,000 joules of energy. If I did my math right. Okay. And so I can find out how much energy it's going to take to put my cart at the top of the hill by just calculating how much potential energy that cart holds at the top of the hill. Because that's how much energy I had to take to get it up there. That pi at the bottom of electrical energy must be the same size as the pi of gravitational energy at the top. Okay? So whenever you see a problem like this and they ask you how much energy does it take to get something to the top, just find the gravitational potential energy at the top because that's how much energy it would take to get you up there.